So I've been working on this particular patch. Initially, all I was planning to do was to fix the broken unit tests for BSymLink. And it turned out that after I submitted the initial patch, Axel and Adrien found that they actually let me know that this was an API regression. I actually assumed that the symlink functionality, the API BSymLink, was actually going to be similar to that of posix, but it turns out there's a couple of subtle differences. And the unit tests that were failing pointed that out, or at least highlighted that. So the change is pretty simple, at least from the API perspective. You can see the difference here in this patch for the symlink class, the BSymLink class. So BSymLink takes, let's actually look at the code here. So symlink.cpp here. So a symlink, once it's been initialized, will take, you can load it with and then link.set to, say, path to my link, which would be a path to a symlink. And assuming this returns, be okay, then you should be able to call readLink with a buffer and pass it in the pointer to some memory and how big that memory is. And the idea with readLink is that it will read the contents of that symlink into the buffer. And we'll copy no more than size bytes into that memory. The difference in the B API versus in posix is that readLink in posix, the posix function looks like this, where it actually returns. If we look at the return section on success, these calls return the number of bytes placed into buff. So the difference is that in the B API, readLink is actually supposed to return the length of the link, and buffer ideally ends up being a null terminated string. So the value returned is not the length of the string written to buffer. It's actually the length of the contents of the link. So if you pass a size that's not actually large enough to hold the whole link, part of it will be written to buffer, but the whole length will be returned. So this turned out to be a regression, which we've fixed here. So this is the actual call to BSymLink ReadLink. And you notice here that the only real change is that we don't check that the size we don't check that link length is actually larger than the size of the buffer that's provided. But this is not the whole change, because also kern ReadLink had to change. So this, if we can actually follow how this call happens. So kern ReadLink calls common ReadLink, which then looks up the node and then calls read symlink on the file system itself. So this is going to be in an implementation detail of whatever file system you happen to be using. We can look at the BFS implementation here. That'd be in kernel interface. So yeah, I have it up right here. BFS ReadLink. So basically it takes the volume, the inode, an output buffer. This is what we want it to write the link contents to, and a pointer to a value which is the size of that buffer. So the idea is we're telling BFS we have a buffer of this size we want you to write into, and then after you've written into buffer, also update the size to tell us what the actual link is. So this actually ended up being behavior that was wrong too. So in order to fix this, we had to fix this in BFS also. We can go look at the difference here. So this is what we ended up doing instead. So here there was a check to see that the size we were setting to is actually less than the buffer, which is not what we want. So because we don't want to set it to the bytes copied, we want to set it to the length of the link itself. So instead, we skip this check. We read the contents into buffer, and then so basically copy up to buffer size bytes into the buffer, and then we clobber buffer size with the actual length of the link. And this is for long symlink. There's a second branch here, which is if it happens to be a short link, then it lives inside of the inode itself. So we can actually just mem copy the content. So here we check what the actual length of the link is. That gets set as the output parameter buffer size that we basically pass to the caller via this pointer. Then we figure out how many bytes to copy. So if the link length is smaller than our actual buffer that has been provided by the user space program that called this, then we are going to say we want to copy the entire link. Otherwise, we only copy up to buffer size. So the idea, if you pass a buffer that's only 2 bytes, but the link is, say, 20 bytes, maybe the link starts with like temp foo my link. If you pass a buffer here that's only 2 bytes, so this would be 2, then the actual buffer would only have written like, /t. So we have some tests for this. Let's see. What is this? Symlink test. Yeah. So we have some tests for ReadLink. These are the ones that we fixed recently, and these all pass now. So I can run them here. So before this initial version of this patch, these did not pass. There were a bunch of failures. If I run the symlink tests, these all pass. So you can see like an example here is that we have this is a BSymLink object. We set it to the path to dearlink, which will be I don't remember what this is. I think this is defined in node test. Dearlink name, yeah. My autocomplete's not working right. Dearlink name, yeah. So that's set to here. So temp link to dir1. And that will be a link that points to existing dir name. Yeah, so basically the test makes a directory, creates a link from existing dir name to dearlink name. So the idea here is that we are creating a link out in the setup for these tests. Here we initialize this BSymLink object to point to that symlink. Then we read the contents of that link into this small buffer here, which is only 2 bytes. And then here we expect the length to actually be the length of the actual contents of the link. But only 2 bytes were written to this small buffer here, including a null terminator. So before this patch, the behavior was different. The actual link length that was returned here would have just been 2 because it would have been the number of bytes copied. So that's fixed now and this passes. And the problem is that because fixing this involved fixing the file system itself, that means that we had to fix every file system because almost all of them were wrong. So for example, here's a patch for ButterFS. So we have ButterFS ReadLink. This one was actually really incorrect for a couple of reasons. But now it does the right thing. So it checks that the inode is actually a symlink. reads the contents and then actually sets the buffer size out variable, out parameter to the size of the link. There are some other ones that are, yeah, ext2 is pretty similar. So ext2 readLink, it was actually wrong for a couple of reasons. So for one of the big reasons this is wrong is not only is it not doing the right thing, so we're actually setting the output parameter to potentially a different value than the actual link length, but we're also using just normal memcopy, which will be a SMAP violation because the kernel actually isn't allowed to read user memory except for some special circumstances. So that required changing to user memcopy here. So anyway, this patch is basically done, except there's one final part which I noted in my last update here, which is that we don't, oh, it looks like there's some changes here, some notes. But anyway, one of the things I didn't update was reiserfs. So there is a reiserfs implementation here that's not compliant here. Let's take a look at what it does. Actually, first, let's just test it. Let's just see what happens if we try it. So I happen to have an Ubuntu image here that we can use. Why didn't that work? Oh, wrong path. Oh, I need to update my script. My little script for running VM is kind of janky. I need to take this minimal image out. So I'll just start this Ubuntu image up, and we'll create a reiserfs file system that we can use for testing. I guarantee it's not going to work. So let's do a build of that image while we're waiting. Okay, so yeah, terminal. Come on. And then reiserfs. So I have attached to this VM a few different disks. So we have this this is the minimal images built by the Haiku build system, and then this is a data disk that's like a QCOW2 image that's 10 gigabytes that I use for testing various things. So let's see. Yeah, so I want to make reiserfs here. Let's mount it. And then we'll just make a couple of files here. Make a directory called foo, and then we'll edit a file called bar. Hello, reiserfs. And then we'll just make a symlink. So, oops. Okay, so we have a link that points to foobar. Okay. So that should give us a good test bed for making sure that this works. So let's shut down this VM. Okay, looks like our image finished building. And okay, so we'll run that Haiku image and let's see what happens. So this should, first boot, and then, so now we should have a reiserfs volume. Yep, there it is. Okay. Looks good so far. If we try to, oops. Okay. Well, looks like we got some work to do here. So first, looks like stream reader read at. Oh, memcopy. There's another SMAP violation here. So this is just a security feature. Again, it prevents. The idea is that the kernel shouldn't be able to read or write any arbitrary user memory to prevent, you accidentally corrupting memory or for security reasons. So we just need to change that particular code. let's see, if we want, let's go open the jam file here for reiserfs. So stream reader, I bet that lives in volume. No, maybe node. Where do you live? Okay, well here's where we create a stream reader. So, oh, here we go. So it's calling read at. Okay. So what do we call memcopy here? So it looks like, if we look through here, it looks like it's iteratively reading through chunks of this stream. Indirect item. Ah, here we go. So this looks wrong. So what we want to do here is we need this to be user memcopy. And then this is a little too long of a line, so we need to break this up. We don't want to be past 80 characters. And then let's fix this cast. No C style cast. Actually, this should be reinterpret cast. Okay. And then if copy results is not okay, then return copy result. I think that's right, because it doesn't look like there's any state we have to clean up here. I don't think. Yeah, it doesn't look like it. So I think it's safe to return from this spot. Okay, so that's one. I saw another function, redirect item. Is this the same? Oh yeah, same deal here. So we don't even need this. We can just do return user and copy. And then we might as well, while we're changing this line, fix the cast too. Okay, let's try that again. Let's see if that's any better. Normally, when I'm working on Haiku, I actually don't generally do it on Linux with a cross-compilation setup. I usually am working on Haiku directly. But I find that when I have this kind of setup, it's a little quicker to just be building these minimal images and booting them with QEMU, with KVM. So when working on the kernel, I tend to do this. Anything user space, I tend to just work directly in Haiku. With some exceptions. I mean, working on the kernel in Haiku, directly in Haiku itself is fine. The way I tend to do that is just by running the install target in the build system to point to a a file system that I can boot from the bootloader, and then just install and then reboot. That's a little more time consuming than running a VM like this. So I tend to do this if I'm working on anything kernel related. Okay, so far so good. Let's mount the file system, and okay, so we can read the file. That's good. Let's open the terminal and let's see if we can read the link here. Okay. So we can read the link. That's good. Okay, so at least that works now. Now let's look at a test program. So I have a test program. I'm going to show it on another screen here. So this do it program, all it's doing is making a 4-byte buffer, calling readLink. We expect that readLink will return the number of bytes written to buff. And so that's what happened here. It returned 4 bytes, FOO/. Great. The other one is testing BSymLink. So we're initializing BSymLink object and calling readSymLink with a 3-byte buffer. And so we get the length returned, which should be the length of the link itself, and then the contents written to the buffer. So here is where we can tell it didn't work right, because we got back 3 bytes, and we know that the link is longer than that, because that's much longer than 3 bytes. So we know something's wrong here. So let's look at how that works. So reiserfs kernel interface. Okay, here it is, reiserfs readLink. So it looks like we check if the node is the link. That's good. So that's something that we want it to do. And then it calls readSymLink. And it looks like it's passing buffers, the buffer size is a value, and also the pointer to buffer size, which is right. We expect it to do that. So let's look at what that does. So that calls just calls read object. So it looks like this is like a shared function for reading file contents and a link at the same time, or either or. So it looks like it checks. It seems like kind of a redundant check, but maybe we don't need to deal with that right now. And then creates this stream reader object, and then calls readat. Okay, so then looks like readat is going to take bytes read. So it's going to copy at most buffer size, I believe, at most buffer size bytes into buffer, and then set bytes read with the number of bytes copied. So that's fine. That's not really what we want, but let's see how it works here. Okay, get stream size. Oh, that's interesting. What does this do? It seems like probably a value we want here. So it looks like it sets fstream size with the actual size. Do we expose that? That would actually probably be the exact value we want here. Looks like it's right here, fstream size. Doesn't look like we actually return it anywhere. So maybe we should add. Maybe what we should do is not touch. So if we, in theory, if we didn't touch this function at all, readat, because it looks like this is used by a bunch of different code here, so modifying that might not be safe. Yeah, it looks like it, yeah, so it's used in a couple places. What is this particular one? This is probably read object, yeah. And then read object, I think, is called by a bunch of stuff. It looks like two things. Oh no, just readLink? Huh. Okay. So it looks like read object is only called by read. Okay, so this is maybe some. I'm not sure if this was ever actually finished. So it's possible that the author had some intentions for this code to be reused. But anyway, so I guess we could change the way that this works. Since we know the stream size, we could just change readat to return the actual size of the stream. Or we could add a member to stream reader to actually return the length. Maybe let's start with that. That seems like a safe place to start. Maybe we'll add it right here. So it's an off-t stream size. Okay. And then, so now that we have that, let's look back here and read at. So it looks like read at, okay. So read at's doing what we want in terms of writing into the buffer. We've verified that, but we want to change it here. So reiserfs, oh, looks like read at's also called. Okay, so we don't, yeah, I don't really want to touch that if it's used by read here. But what's it called? Read symlink? Oh, read symlink. There we go. Okay. So this is calling ReadLink, which calls read object. And is read object only called by? Yeah, read object is only called by ReadLink. So we can, but I actually feel really strange calling this, changing this just for read object, because it seems like this is more generic. Maybe we should make ReadLink do exactly what it's supposed to do. So let's take this and let's change it here. Let's change ReadLink to be a more specific thing. So I'm just copying this here for reference, but I want to kind of redo it. So let's just, for now, let's verify, let's replicate some of the sanity checks here. They may not be correct, but I don't want to change the whole world all at once. So let's see, let's check if node is null. I'm going to change these conditions around because I kind of want to have some early exit checks here. If node is null or bytes read is null, or, so we don't have to check offset because we don't have that parameter. So if either of those are null, return the bad value. Good. And then let's get rid of that. So we've got that done. So then, yeah, if node symlink, if it's not a symlink actually, the bad value. Okay, so no need for these comments. They don't really give us much extra info. Okay, now we create the stream reader. If reader.init check isn't BOK, then return reader.init check. I assume that's not doing work. It should just be copying a member. Stream reader init check. Stream iterator init check. Fstream tree iterator init check. Okay, well, since we're calling so many functions here, I'm sure the compiler is smart enough to optimize that away, but let's be a little better about this. So results equals reader.init check if result. Okay, so there we go. That takes care of that. Now we have the read at. So the offset is 0. We're reading from the beginning. And we're copying. And in theory, if we didn't have to change any logic here, we could actually just say return reader read at, because I think read at returns status t. Yeah, and read at is going to set bytes read to currently the number of bytes copied into buffer. So that's not what we want though. So let's say we change this. First, let's make another variable here, bytes copied, and we'll set that to buffer size, just initialing it to that, and then we'll pass in a pointer to it, bytes copied. Okay, and then store store this results. And actually, I think, yeah, that should be okay. And then we'll return, now we need to set bytes read. We'll need to rename that variable. But we want to set it to reader dot, what do we call that? Stream size? Yeah, that's the property, that's the number we added. And then return result. So this looks like it could work. Let me build that while I think about it, because I don't think I see anything particularly wrong with this. Maybe we could clean this logic up a bit. The question is it safe? Is stream size going to be initialized before readat is called? That may be, yeah. So that's okay. So it has to be done in that order. This is kind of janky. But one thing we need to do is change this parameter. We won't want to call it that. We want to call it link length. And then we need to change it in the header. ReadLink. Link length. And then, good. Okay, so it's done. Let's see if that worked. Should mount automatic. No, actually, there's a new image. Never mind. We'll need to mount it. Good so far. And then it's good. Good so far. Oops. Oops. Okay, that's good. And then link. Great. Now let's try our little test programs here. So first we'll check to make sure that the readLink posix function works correctly. That looks good. And then we'll check to make sure BSymLink does the right thing. Yeah, that's much better. Is it the right? Is it the right number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Okay, so it looks like that works. Great. I'm satisfied. So let's just make a couple of final changes here. So we changed this to link length as the name. Link length. Okay. And let's change the function in kernel interface also. Read symlink. Oh, actually no, we can't change that. I think this is good. I don't think we've made any changes that are gonna make this like really a lot different. I'm more concerned with just fixing this particular behavior. We can make deeper changes later. Let's see what it looks like. So we've fixed the SMAP violation here, and we've fixed SMAP violation here. Now we've added this member, and then that indenting is wrong. Let's fix that. This is stream reader here. Okay, that should be better. Okay, that's better. I don't see any extra white space. We've just changed this parameter name and changed it there. Let's make sure it compiles again. And then I think we're done. We'll just update the patch. And then we can address some feedback from WattleSplash and Pocomandy, because it looks like they left some on the ticket, on the patch in Garrett. So, oops. So I'm not focusing on a big commit message here because I'm going to add this to my existing commit message. In fact, is this done building? Build failure. How did I break it? Bytes read. It's not declared. Oops. Looks like my rename failed because I renamed it to link length, but it's read. Yeah. Link length. Okay. Actually, before I do that, I'm gonna sync with master. Oops. Let's pull the latest changes from master, because I'm sure in the last few hours there's probably some stuff that has slipped in. Yeah, there's a little bit. Let's get any tags that might have been. I don't know if anyone's doing builds right now, so there might not be any tags. Oh, there's a few. Okay. So let's squash these. So these are the two commits I just made. We'll squash them into this patch. So, okay. So we want to add to this section, because these are the other miscellaneous file system updates. So which files did I change? Oh, let's do this. Reword. Okay. Now, right here. So it looks like we changed reiserfs volume, reiserfs iterators.h, and reiserfs, let's see, volume.h, and iterators.cpp. So yeah, that's 1, 2, 3, 4 different files here. Okay, and then I'll just sort all of these. And then I'll say, I'll point out the SMAP violations here. I'll do let's see. So I'm just showing the actual changes here so that in the reiserfs code that I just made, so I can see where I fixed the SMAP violations. So this was in user memcopy in correct item. Okay. So let's make sure this builds, and then we should be good. Push a copy to my branch while it's building. So while that's happening, let's look and see what they've said here. Okay, so the first one is oh, that's true. Yeah, it could. Yeah, we could just use min instead of this this ternary. That's fair. That's true. There's probably a few places where we do that. And then let's see. That's true. Yeah, actually. He's got a point, because it's definitely going, yeah. Okay, well, that's a good suggestion. We don't need to use stir-in then for this. So that's a great point. And then, yeah, okay. So this is fine. We'll just make these changes. And then I think those are the only feedback I've gotten so far. Great. So let's just do one more test just to make sure this works. And then we will make those final changes and update the ticket. And then I need to mount this ticket, or mount this volume. I also want to mount this VVFat. So by the way, this QEMU VVFat thing is this is a feature of QEMU I use all the time. It's really handy because if you look at this, my script that starts this VM, I'm telling it that I want to make like a FAT32 volume that is basically just mapped to the contents of this directory. So I basically have it mounted to the, I have this directory that holds the built unit tests from the Haiku project in this volume. So it makes this volume called QEMU VVFat, which is pretty cool. I use that all the time because it saves you from having to, make a new image and create a file system, mount it over loopback, copy the files or whatever. QEMU just kind of automates this away a little. It's a little buggy though. It doesn't work all the time. I keep spelling riser wrong. Good. 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 And then good. And then ReadLink. Just a reminder of what these programs are doing. I have it's basically just making a BSymLink object and then reading the contents and making sure, just echoing to the console what the link and what the returned length and the actual buffer contents are. This is the same thing that's being done in the unit tests. However, the tests don't currently work on file systems that aren't BFS. This is a limitation of that setup. I plan on at least making tickets that describe how we should have some more robust file system tests. We don't currently have them. So this all works. So let's fix some of these things. So one of the things that had to be changed here that Polkamandy is pointing out is that because we changed the way that the file system implements reading a symlink contents, we had to change the readLink function in libroot, which emulates the posix function readLink. Before, we basically just assume that it's going to return the number of bytes copied, but it doesn't do that anymore. So the way I implemented that was I added an include to string and just use stir and len to basically read the length of the string in the buffer, using stir and len, saying just in case that buffer happens to not be null terminated. So then the max number of bytes it will read is buffer size. But Pocomandy is pointing out that that's totally not necessary, and he's right, because if the link is actually smaller than the buffer, meaning the whole thing fits, then link len will actually be the correct thing to return. However, if it is larger than the buffer, then the buffer size is what we return. So we actually just want to do exactly that. So let's fix that. Let's see. Libroot, this is in posix, I think. Link.c. Oh, uni.std, that's it. Okay. So readLink calls readLink at, this is the function that he was talking about here. So I'll make a note about what I just said. So if the buffer is larger than the link contents, then link len is the number of bytes written to the buffer. Otherwise, buffer size bytes will have been written. So we want link. So this should be right. We don't need this call. We don't need to include string.h anymore. What includes cmin? So this whole time I've been using studmin, but Slash was suggesting cmin here. That's great. Let's see where that's included. Let's see. Oh, not diff. I want grep. It looks like it's not used at all in libroot. Maybe it's min-c. Is that what he said? Let's see. He said probably use min-c. Oh, I got it backwards. Min-c. Okay, let's make sure that that works. And then see if that should work fine. I don't see how it couldn't. And then, so that's that, and then here he says something about lstat. Let's see what this is about. Oh, okay, so he's oh, okay. That's a good point. So this particular function here is in the build code. So this, where does it show the full path? Anyway, yeah, src build libroot. So basically the idea is that a lot of the build system is depends on Haiku APIs. But of course, when you're cross-compiling on, like, say Linux or FreeBSD or macOS or Windows, those APIs aren't available. So there is like a polyfill here under build, which implements all of libroot, or enough of it to satisfy the dependencies of the build system. And that lets the build system be written to target only Haiku APIs, but run on other platforms for cross compilation. So this kern ReadLink is actually just the user space polyfill for non-Haiku systems. And so the way I dealt with this is because its behavior is going to be it's implemented in terms of ReadLink, but the way I ended up implementing this is just by having a buffer that is guaranteed to be big enough to read the contents have the contents of the link, read it in, and then only return the size, the link length, which is the total number of bytes written into this temporary buffer. But Adrien Pocomandy is saying that there is a less dumb way to do that. So I think he's right. Let's see what he linked to. He linked to the man page for ReadLink. And he says lstat. That's a good point. So we can use lstat to get the size. He's totally right. This is dumb. So let's fix that. Ooh, let's test our change really quick to make sure that it worked. So we changed the ReadLink implementation in libroot. So that's what we're testing right now. This ReadLink at. So we changed this instead of just doing sterlen to just return the min of either link length or buffer size. Okay, seems to be working just fine. So let's move on to, let's fix that problem he just pointed out. So this is in build libroot fs. Okay, so I think his point is basically we know the path to the link, so we can use lstat to get the length and not make this copy. So that's totally reasonable. So what is real path? Oh, I see. This just looks up the path. I think there's some relative path mumbo jumbo happening here to deal with path differences on Haiku and the host system that's cross-compiling. So let's ignore that. So, okay, so we don't want this temporary buffer. And we want to read into buffer size. That's great. So we don't need to change anything here. Does ReadLink take, yeah, it takes a value. Okay. So if we can't actually read the link contents, we return an error. So now we don't need to do any copying. We do probably want to actually set a null terminator though. Just in case. How do we do that in this function? Bytes read is less than buffer size, then buffer. I think it just sets, yeah. Bytes read go. So we'll just make sure that it's null terminated, even though it probably isn't. This looks like a cast problem. Buffer size. Oh, no, I put the underscore on the wrong part. Oh, now we are, okay. Now we are comparing two different types here. So this is a S size T, and this is a size T. Okay, so we'll cast this one to a size T, since that will definitely fit. Okay, now we don't need this copy, which is great. And then here is where Pokemani's suggestion comes in. So struct stat buff. Okay, lstat. Okay, so we want to do and then struct stat link stat, and then we want to do lstat of path. We want the real path sister, and then now, if that fails, what do we want to do? We need to change this into I'll just do if is not equal 0. I think it returns 0 if it succeeds. That's probably not the right error. Let's think about that for a second. So if we have, actually, let's see what it does. Returns information. It returns information. Oh, here we go. On success 0, on error -1 is returned, and error no is set appropriately. Okay. Oh, that actually makes it easy, because error no value, there should be an equivalent error no in the B API. So that's good. So we can just return error no. Now we know we have the link lstat. Hard links. What did he link to? ReadLink. ST size. The required size for the buffer can be obtained from the stat ST size value. Okay. Good. So we can do buffer size equals link ST size. Okay, I think that's good. Let's look at this. But I need to change that comment. Okay, let's clean a few of these up. So first I need to commit this one. And then here we need to change this. Okay, so I'm going to return the length of the link, not the number of bytes written in the buffer to emulate that here. We will we use readLink, read the link's contents, and then lstat to get the full length of the link to set. Yeah, okay. And then oof, what happened? My editor froze. What's going on? I might have to kill my, I might have to kill my editor. I think it's it doesn't seem like it's stuck. It's just doing something. I'm not sure what it is. Oh, I'm gonna kill it because oh no, it woke up kind of. Well, let's start again. Where were we? ReadLink. Okay. We'll leave that comment out. I think it's pretty obvious what's going on. Okay. So I think we're good here. We fixed the comment. So on Haiku, kern readLink will return the length of the link, not the number of bytes written to the buffer parameter. To emulate that, we are using readLink to read the link's contents and then lstat to get the full length of the link. Now read the length of the link using lstat, since readLink returns the number of bytes copied to the buffer. Not, yeah, okay. So it's pretty clear, I think. Doesn't look like we have any lines that are too long. Good. But we do have some extra white space here. Oops. My Emacs server stopped when I restarted. Okay. Don't you use lstat instead of an extra buffer. Okay. And then, all right. So that takes care of this one. And so we took care of this change to libroot. This change to the fake libroot that's used for as a polyfill for host systems that are cross-compiling. Then it looks like he's pointing out that maybe we should use, looks like, I think, yeah. So he's just saying, I've used this ternary in a bunch of places. So we should probably just use min-c. Fair enough. It's easy to change. So let's fix all those. So let's see. First place is BFS kernel interface. Okay. So we can just do that here. Oops. Okay. So let's change that here. This ReadLink. Okay, so here is where this ternary operator is. So what they're saying is, instead of this, I basically reinvented this. So there's no point in reinventing that. Let's do the same thing everywhere else where we've made that mistake. I wouldn't say it's a mistake. It's just they're right that it's silly to do that over and over again. Okay, and then netfs good, be good. Packing leaf node. This is to copy. So the same thing here. Okay, and then package link symlink, so same thing here. Okay, so st bytes to copy equals, let's see. Okay. And then, good. Let's copy, good. This is the reiserfs change we made earlier. And then, oh, you know what? I just realized we probably didn't update the comment for this. Let's do that. So it looks like there's no comment in the header. So, yeah. So we changed this to link length, but it's still bytes read. So okay. Good. So let's see. What other? Are there any other ones we missed? I don't think so. I think that's all of them. Okay, that looks good to me. Let's build it. And then we will run, we'll run the same test we've been running, and then I'll run the unit test also. Oh, build failed. What do we break? What the heck? Oh. C was not declared in the scope. Oh, you know what? I think that's fine. I don't actually want to use min c in this particular code. I'll use std_min. Because the reason Waddle_Splash wanted to use min c in libroot is because that is supposed to be the C library. But this is different. This is C++ code here, so we can use std_min. So where else do we do that? So we also did it in ISO 9660. We don't want to do that. We want to use std_min and then package link symlink, and then is there one more? I think that's it. Okay, now this should build. It should build just fine. So once this is built, then make sure the unit tests are built. We'll run them. We'll also do that quick little reiserfs test I was doing. I had been spot checking other file systems, so the ones that I've checked so far are, I've checked BFS obviously because we run the unit test there. I've fixed and tested Btrfs. A lot of these aren't applicable, like CDDA. I didn't test exFAT. I did test ext2. FAT doesn't support symlinks. I didn't test this one. And I didn't test NFS, but I did fix this one. NFS4 looks correct. NTFS looks correct, and I verified that it is correct. PackageFS also is correct now. You know, I didn't check RAMFS. What does it do? Read symlink. It's possible that this is wrong too. Copy the link contents. Buffer size equals 2 read. What is 2 read? Oh yeah, this is wrong too. Okay, I'll fix this one afterwards. Let's see. Why did you fail? Min is not a member of std. What header is std_min? It's probably from utility. Algorithm. Okay, so we're just missing an include of algorithm here. Algorithm. So I think this will fix it, and then BFS kernel interface. Okay, let's try that. There we go. So let's see if that works. And then we'll we'll do ramfs also. That work? Candidate expects 2 arguments, 1 provided. Oh, I didn't do that right at all. Maybe I don't need to include algorithm. Maybe it's failing because I'm a dummy. Let me see. Oops. Yeah, because I made that change kind of robotically, and I realize now I messed it up. So it should be okay. And then kernel interface. Oh no, that's right. So maybe I do need algorithm here. Let's make sure I didn't. Make sure I didn't goof that up too bad. Okay, I only messed it up in BFS. That's good. So hopefully this will build, and then we can move on. Ooh, this is taking a long time. Yeah, okay, so I do need to include algorithm. This kernel interface. So looking good so far. All right, so let's give it a go. Let's give it a go. Let's see what happens. So boot it up, and we'll mount those 2 file systems. Read only, good. And then let's see. Let's open the terminal, and yep, good. And then looks good. Now let's run the unit tests. So I have them. That QEMU VVFAT volume has a copy of the tests. So I really want to automate this at some point to be a little less dumb. But what I've been doing, if I'm not working on Haiku using Haiku, is that I tend to just copy the unit tests into this particular test the data volume. The reason is that a bunch of the tests essentially require BFS right now because they do things like search for search for files handled by a certain application MIME type, or searching for files of a certain type, looking for files in the trash can, that sort of thing. So they depend on Haiku APIs. They depend on a lot of those tests depend on BFS behavior. So I want to automate setting this up so it's easier to run from a virtual machine like this. Well, it looks good. I think we're good. I think we're done. Except now we want to do ramfs. Let's how do we make a ramfs? I might have to save that for another time. I might have to research that more. I'm not really sure. For now, I'm just going to submit this updated ticket. So these are just suggestions. So I don't have to update this status at all. And then push this, and then I'll push it to Garrett, and then acknowledge those thingies. So this always takes a little while, unfortunately. Let's see most of these tabs. So let me just close some of these. Actually, I think there's a better way to do this if I do only comments. Just do it this way. Good, act that. Good, and then last one. Oh man, you're right, that's way better. Okay. So we resolve those, and then I think there is one additional one. Is that right? I think I have a comment here. That's good enough. Just do that. Okay, and then go back here and reply. Well, that's it for now. I think I'm out of time for the day.